And thank you all for being here today, especially with the tube strike on. Now you're here to listen to me ramble on about MLOps and MATCHESFASHION. So today's talk is not going to be a technical one. It's going to be a fairly high-level talk where I speak about how we introduced MLOps and some of the workflows we first developed on our journey. So before I get started, how many of you here have heard of MATCHESFASHIon? Okay, about 3 people. Of the people with the hands up, have you bought from MATCHESFASHIon or not? Take that as a no. Okay, I'll carry on then. So MATCHESFASHIon itself started as a single physical store in London in 1987. And over time, that grew to around 4 physical stores by the early 2000s. And around about the same time, we launched the e-commerce side of the business, where we saw significant growth. And fast forward to today, we now serve customers in over 170 plus countries and sell over 650 plus different brands. A typical customer would come and spend between £200 to maybe a few £1,000s in a given transaction. But we also have high value clients, which are like actors, celebrities, and royal family members who would come along and spend hundreds of thousands of pounds in a given transaction. And they'll do that on a daily or even a weekly basis. So as you can imagine, they're a big, large revenue stream for us. So jumping straight into our journey. So how was MLOps introduced at MATCHESFASHIon? So I joined the company in 2020. When I joined, there was one model in production, and this model was on its last legs. The data scientists who built the model had left the company at that time, and so this model was only trained once, and the data was drifting. Its monetary value it was generating was dropping, and stakeholders were becoming very angry with the model. And so that's where I came in. And I came in and pitched a really revolutionary idea, which was to retrain and monitor the model, right? It's a very simple thing to do, but a very powerful thing to do. There was initial pushback by this, and once I got the go-ahead to work on this, I built some ad hoc pipelines to monitor and retrain the model, and suddenly we saw the model's performance return to the level it was supposed to be at. Now, stakeholders now were, again, feeling relief, but also they were now educated with regards to how data science models need to be maintained post-productionization. And so DS confidence within the business is now growing, and our stakeholders are becoming more open to us with working with us with regards to building models. And so this moves me on to the kind of the workflows we first developed in MATCHESFASHIon. So we developed 3 main workflows to begin with. One is our notebook workflow, then a workflow around data monitoring, and then a workflow around reproducible data sets. So it's quite early on in the pipeline. So jumping straight into the notebook workflow. So at MATCHESFASHIon, we use Databricks. If you're unfamiliar with Databricks, this is essentially a notebook in the cloud powered by PySpark. So we can build large distributed machine learning models using PySpark ML. You can also use to build GPU models as well if you want to. We also have the option to do single core models via your traditional scikit-learn models as well. So Databricks at MATCHESFASHIon has 2 accounts or 2 environments. We have a dev account and a production account. When we get the go-ahead to work on a model, a data scientist will come in and do the work in the dev account. So that would be the analysis, that would be the model building, prototyping, etc. Once that's been finalized and we've got happy with the model, we would then work on the pipelines. So that'd be data, inference, and training pipelines. But then we would then need to move those pipelines from dev to prod. But how do you move it from dev to prod? We could copy cell by cell, but that's not a very elegant way of doing things, right? So luckily, Databricks has a GitHub integration. And so we can just push the notebooks to GitHub and pull them in prod. And that way we have information flow via Git. And we have the exact same notebook in dev and prod. Obviously, you can do vice versa as well from prod to dev if need be as well. And then from there, we would then productionize the notebook. So productionizing notebooks is a piece of contention for me, because I'm not a big fan of productionizing notebooks. So could I have a show of hands here who is a fan of productionizing notebooks? Nobody, which is good, which is nice to see. I personally don't like productionized notebooks because it doesn't lend itself well to maybe code reviews, PRs via GitHub. It doesn't play nicely with CI/CD, and these notebooks can get very long as well. So how do we actually productionize our work at MATCHESFASHIon? Well, we productionize a notebook, but not in the way you would expect. So once we have all the pipelines in place in prod, we would then modularize those pipelines into Python modules. So take them out of the notebook and create Python files. And from there, they will be pulled in locally where the data scientists can create the unit test and do the code linting, etc., and create the GitHub actions as well. And so once we're ready to release a version of the model, or code base, for example, the data scientist would release a tag with the push, and that push would package that push would let GitHub Actions know this is a release, and so it would then package that model and push it to our PyPy index in code artifact. That's our own personal PyPy MATCHESFASHIon index in the cloud, and then from there we can install that package into a notebook, and we can lock the package version in the notebook now as well. And so from there, the data scientist should only write 3 or 4 lines of code to run the pipeline that is needed. And so we've gone from the entire code base being in a notebook to now the heavy lifting being done in Python modules, and the notebook only having 3 or 4 lines of code to actually run the pipeline that is needed. And so that was the first workflow. And I want to move on to a data monitoring workflow. So imagine a very vanilla situation where data scientist isn't familiar with data monitoring or MLOps in general. And so you may retrain the model at a given cadence, right? So if it's training day, you would say, if it is training day, sorry, you would retrain your model and then run inference. If it's not training day, you would just load in the latest model and perform inference. But we want to be smarter than that, right? So at MATCHESFASHIon, we have built an in-house framework based upon PySpark to detect data drift. And so this drift, the reason we built it in-house is because we can leverage PySpark and calculate metrics very quickly on large data sets. And so the drift check up there is our PySpark framework, and all the metrics are dumped into MRflow. And so if drift is detected, we would train the model and perform inference. If drift is not detected, we would run inference directly. And the powerful thing about tracking metrics is that we would have an idea of decay with regards to the model. How often is the model decaying? Is it seasonal, etc.? And so once we have like a year's worth of data, the following year we should have an idea of when the model needs to be retrained. And if it doesn't follow the previous year's pattern, there could be things like concept drift or other things taking place as well. And so that was a quick tour of how we do data monitoring. When I want to speak about how we do reproducible data sets for our machine learning models and also on an inference as well. So again, going back to your vanilla example, one of the simplest ways of saving data is just to take snapshots. Every time you train a model or perform inference, take a snapshot, dump it to S3. So that could be your Parquet files, that could be CSV files, that could be anything you want. But the issue is there, anybody who has looked at S3 bucket, we realize it gets messy very quickly. It's the Wild West within a year, right? There is data all over the place. It's very hard to find data, and it's pure chaos. And so what we do at MATCHESFASHIon, we use something called Delta. So Delta is embedded in Databricks, and what Delta does is calculate the kind of change between data sets, and that's a very powerful thing for us to use. So as a data scientist, you have 2 options of taking two snapshots, so 2 ways of capturing how your data has changed. So you can do Delta snapshots, which is like the S3 example above, but with one distinct difference. Or you can do CDC, which is change data capture, and this is also powered by our Delta technology as well. So a Delta snapshot, you would use this in an instance where your data changes a lot between iterations. Say 30–40% of your data changes between data iterations, then you want to take a snapshot. Otherwise, it's redundant to take snapshots. You want to use CDC. CDC, what the CDC does is just tracks what rows have changed between iterations on your data sets. So for example, that could be inserts, updates, deletes. That's all it tracks in CDC. And it's a very powerful thing. And now as data scientists, we now have access to these data sets via SQL because Delta natively is embedded in SQL and Databricks. So as a data scientist, they can come along and just do select star from model data set. And that's it. We now no longer have to navigate S3 buckets. We can just do an SQL query to access the data. And we can also do select star from data set where version equals 4. For example, we can now explicitly recall the 4th version of the data set that was used for inference or for training. And that version is tracked at the data monitoring phase and stored into the MRflow experiment. And so this just overall increases visibility of our data and makes things a lot easier. Things aren't hidden in S3 buckets anymore. Everything's all visible and transparent for everyone to see. And so what we would then do is put all these pipelines together. And so you have those 3 individual pipelines. You've got your notebook workflow on the left. You've then got your reproducible data sets at the bottom there. And on the top half, you've kind of got your drift or data monitoring detection as well. And this would encompass our entire model pipeline. Obviously, this is a smaller component in the bigger component of moving pieces as well. There's always a bigger fish, right? So that component I just showed you now is the green component here. Oh, sorry, I'm not clicked. So that component I just showed you on the previous slide is that green component there on your screen now. So this is a very diluted down way. I say diluted down because it's very, very vanilla of how we would do real-time and batch predictions. So in the real-time world, we would containerize our APIs, which would be completely stateless, and then push them to ECR, and then launch them on ECS. So we're AWS is our cloud infrastructure tool, and then these ECS containers will sit behind a load balancer. And so once the container is launched onto ECS, they would pull in the model or the data that's needed from S3. If it's a large payload of data, it will cache it into Redis. If it's a small payload, it will keep it in memory. And so when the model pipeline runs and new data is available, it can ping this API endpoint for inference, or if a new model is available, it can tell the instances that new model is available, pull in a new model from S3 or our model registry. And that's the real-time prediction world. In the batch prediction world, a model pipeline would run and dump the data to our gold layer in our Delta Lake, and from there, an event will be triggered, letting stakeholders know that new data has become available to be consumed by downstream systems. And unfortunately, I didn't have much time to speak about everything today. But at MATCHESFASHION, we are working on multiple things at the same time. So we have work done on our feature store, our model registry, and we're also doing work on Kafka streaming as well. Kafka streaming is going to be a game changer for us because we can have a canary model and a production model all subscribe to a topic. And then you can have variants of production models subscribed to the same topic. And so you have a variety of models making predictions on the same data at the same time, making them more directly comparable, and therefore making A/B tests a lot easier as well. So Kafka is going to be a big game changer for us. So fast forward to today, and where are we? So pre-2020, during the peak of the pandemic, there was no monitoring. There was one model in production. Models were drifting. There was big loss of monetary value, and stakeholders were becoming very unhappy with the business. And fast forward to today, data is now monitored. We now have multiple models in production. Business is now very confident with data science as a function because we're proving our value, but there is still plenty to do with regards to MLOps and MATCHESFASHION. So that was it. So thank you very much for listening. It's a very quick talk today. Those are my details on screen. That's not a picture of me. That's someone far more photogenic. I don't want to scare you on a Thursday morning with a blurred up photo of me. So thank you very much for listening today.